Hello ladies, we're going to start a new topic, quadratic expressions and equations. So beginning just with 5a, expanding expressions, something you may have done in year 9, but watch through the video, make sure you write down key ideas into your bound reference. Even if you want to be lazy, print them out, put them in, make sure they're there, because sometimes we look at things and we're like, yep, I'm going to remember that. You know what? You're not going to remember. So it's always important to have it in your bound reference so you can refer to it in the future. Okay, so the key ideas for 5a, we need to know what a like term is. Okay, so basically a like term has the same pronumeral part, so basically the same letter part. Okay, so we have different terms. This example, 7x, x is the pronumeral part, x, and then negative 11x, x is the pronumeral part. So they're the same. And then, so that is equal to negative 4x. Okay, so we can add and subtract like terms. And then the next example, we've got 4a squared b and ba squared. Okay, they are the same pronumeral part, even though a is written before b here and b is written before a here, they're still the same pronumeral part. Now, the powers have to be the same as well. So see how we've got a squared b? It has to be still a squared b. Okay, you can't change the powers, otherwise they're no longer like terms. All right, the second point, the distributive law. Okay, how do we expand? So basically everything inside the brackets gets multiplied by whatever is outside the brackets. The second dot point, every term within the back bracket multiplies every term in the other bracket. And basically the third point is what we call a binomial. So if we've got two terms multiplied by two terms, it's called a binomial. Okay, then we've got perfect squares. So a perfect square is when we're multiplying two brackets that are the same. So you can see here we've got a plus b is squared. So your two brackets are both a plus b, and then you've got a minus b squared here. So same thing. And sometimes you may eventually go from a plus b squared just to a squared plus 2ab plus b squared without having to rewrite the two brackets. And then lastly, the difference of perfect squares. Okay, it's just when you've got a plus b, a minus b. So basically those middle terms, so you can see here we've got 2ab and minus 2ab, that disappears and you're just left with a squared minus b squared. So the difference of perfect squares. By definition, a perfect square is an integer that is the square of an integer. So the rules above also apply for a wide range of values for a and b, including all real numbers. Okay. So we're going to do some examples. Now, when you're doing these notes, if you want to, it's in a Word document, you can make space for them. There's not much space here. Okay, you can I suggest you just copy them straight into your books, but you do what you like. I'm not leaving space here. I'm just going to be doing the working out on the right-hand side. And obviously this is a video, so you can pause me, you can rewind me, well, not physically me, you can rewind the video, you can pause the video, you can fast forward the video, etc., etc. Or stop if I get annoying, which I'm never going to be annoying, am I? Okay. What I might do, because I want to keep these notes for future reference, and I hate it when that pops up, but it's all good. Okay, so this is 5a. I'm going to try to write these neatly so they can be referred to if we need to, because sometimes I just scribble and anyway. All right, so we're just going to expand this. So you would have done this in year 9. So I'm not sure how you were taught, but I tend to use the phrase FOIL. So that just means front, outside, inside, and then last. So as soon as you get to do heaps of these, you don't really need to remember this. Okay, but some people when they're starting out, it helps because you do your front numbers or your first numbers. Maybe it was first. Yeah, I think the F stands for first. Oh, well. So that's x times x, which is x squared. And then we've got x times 8, which is 8x. And then the inside is 2 times x. And then the last, which is 16. Now we've got to group our like terms. So x squared, there's no other x squared, so that just stays there. We can add our x's. So 8x plus 2x is 10x. And then we've got plus 16. Okay, so we can do that. And what I might do is just rub this out now. You go away. And rewrite first. Just because I like being pedantic. Okay, question B. What do we got? X plus 8 and x minus 3. Okay, so we do the first, or the front. Okay, so x squared, then x times, and it's a negative 3, so make sure you don't forget that negative. 8 times x, and then 8 times negative 3. It's negative 24. All right, so we group our like terms. So we've got minus 3x plus 8x, so that's going to be plus 5x, and then minus 24. Okay, I'm just going to scroll. All right, we're still on question 4. Let's just do G, which is x minus 7, and we've got x plus 3. Okay, so quickly do this. If I'm going too quickly for you, you can pause. Okay, but you can see my working out is exactly the same. Just going to make sure I don't make mistakes. All right, so x squared minus 4x minus 21. Okay, question 5. Okay, so let's just scroll up. We've got x plus 5 squared. Now you can expand that. We've got x plus 5, x plus 5. And we can do the first in outside, inside, last. Okay, so we've got x squared plus 10x plus 25. Now, if we go back to our notes, remember the perfect squares. Okay, so we don't have to do this bracket. You can jump straight to the end. Some people would be able to do this in their head. So there's so many questions in your textbook. And if you do go on to do methods, you're going to do so many of these that eventually you'll just do them all in your head. Not like the simple ones you will. You're going to get more complicated ones. All right, let's do D, which is a negative 1. So x minus 3 squared. So you can jump this step if you want to, but I'm not going to. I'm going to show you how to expand it. So don't forget the negatives. And then negative 3 times negative 3 gives you a positive, so don't forget that. So we've got x squared minus 6x plus 9. All right, scroll to the next page. And we're on to question 7. Now, this one here, we've got to work out what the missing number is. So you can just see that is a question mark. And I probably should have written that smaller. I'm going to just write that smaller because I'm not too happy. I don't know why that comes up. It's really annoying. I'm just going to write that smaller so I can write the whole thing on one line. So we've got x plus question mark, x plus 2, equals x squared plus 5x plus 6. Now, when we're expanding, so remember we got x times x, which gives us x squared, which is good. And then we've got x times 2, which is 2x. And then we've got this bracket, it's not bracket, sorry, this question mark times x. So we need some number times x. Okay, so we'll do that in a sec. And then some number some number times 2. I'm just thinking in my head. So basically, I might just, because I didn't use a question mark before, I might just do a line with that. Bye-bye, go away. Okay, so basically, you're going to say, well, this part here is going to equal 6. So that has to equal 6. And this part here has to equal 5x. And this number, your question mark, and this number here, your question mark, they have to be the same, okay, because they take up that spot there. So you've got to say, well, what do I add to 2x to get to 5x? Or what, so you add 3x. And what multiplies by 2 to get 6? So that's going to be 3 and 3. So your unknown value, and I'll just scroll up here, your unknown value is 3. So you can do that without doing all this working out. And then I'll do question B that way. And eventually you're going to have to know how to factorize anyway. So this is kind of the step before, in a way. So you may have already done this in year 9. Okay, let me just write it down. All right, so this time you don't really have to look at both the 4x and the negative 21. We can just focus on this negative 21 because we know when we multiply these two numbers, we have to get 21. So 7 times what is equal to negative 21? So 7 times negative 3 is equal to negative 21. And if you wanted to test out, you could put negative 3 in there, and when you do, you'll notice you get 4x in the middle. Okay, so your unknown value, and I'll put that answer there, so your unknown is negative 3. All right, let's move on to E. Whoops. Let's just change that while we're here. So that was C, and this is E. Now, I've learnt something whilst working at home is my eyesight, which has always been pretty good, is not doing too well. It's probably looking at a screen every day. Okay, so the same thing. I don't have to do a lot of working out. I'm basically saying, well, negative 6 times what? So negative 6 times what is equal to 6. So negative 6 times, and then we've already got a negative there. I'm just going to make sure that is a negative. Okay, so negative 6 times negative 1. But because there's already a negative in there, oh, there was already a negative in that one too. So that probably should have been, sorry, that's my bad. That should have been a positive. And I'm just going to make sure that's right. Yes, because there was already a negative in the question. So that's my bad. So your unknown is 1 because there's already a negative here. I don't have to add a negative in. All right, moving on. Now, question 10 I put in because you're applying what you know to a worded problem, basically. So question 10A. All right, so let's just draw this diagram quickly. Okay, so you know that's the picture in the middle. If you want, you can draw a picture. There we go. Okay, so this length here is x, and it's a square, so this length here is also x. And I know it's a square because these two lines tell me that those two sides are the same. Now, this distance, which you might think is the frame around the picture, is 3 centimeters. So what we have left, and I might just use a different color because why not? This distance here is x, so the whole distance minus the length of this side minus the length of this side. So it's going to be x minus 6, okay? So just your picture is x minus 6. And we have to find the area. So I'm going to go back to black. So the area of a rectangle is length squared. So it's going to be x minus 6 squared. And we just have to find an expression. Find an expanded expression. Now let me just scroll up and see if I've got enough space. I do. So you can expand that if you like, but I know that because it's a perfect square, I can just go straight to writing that expression. Now, b is pretty much the same working out. You have two different side lengths though, so let's do b together as well. All right, draw my rectangle. Maybe this is like of a nice beach scene. I'm not going to draw a beach. And isn't that an awesome rectangle? I mean, I'm so good at drawing on this. Okay, so you can see this side is x. This side is 30 centimeters longer, so it's x plus 30. And then the frame is 5 centimeters. Okay, and it's the same. So if we want to just do our length first, so let's do the easier one, the x. So this distance here is just going to be x minus what we don't want, so the 5 and the 5. So it's 5 on this side and 5 this side too. So your length is going to be equal to x minus 10. And then your width, which is already x plus 30. And then we're going to subtract the two sides, which is 5, minus 5, minus 5. So we've got x plus 20. Okay, so we've got these two, the length and the width. Now, the reason I've put them in brackets is because if I don't, I'm not going to multiply both terms inside the brackets. Now we just have to expand that. So x times x is x squared, x times 20, 20x, negative 10 times x is negative 10x, and negative 10 times 20 is negative 200. So I'm going to have x squared, bring your like terms, 20 minus 10 is 10, minus 200. Okay, so I'm going to stop there, and then the next video is 5b.